Right, so I'm back. I'm restarting the live stream after that rather rude ringing of the doorbell. So I was just at the point of, and I think I just pulled that up. I'm pulling up ChatGPT here. I was just at the point, I was reading out just before I got disturbed. But this was a question that I typed in somewhere. I don't even know. Here it is. This will just, so I basically took this little snippet of code, and that's a snippet of code that produced this chart over here, where it produced any one of these charts. So we can produce like one of these lines, and so that's that snippet of code. But I wanted to produce a second line. This particular one is in blue. We could make it in red, but I want to produce a second line. So the way to do it, at least I stuck in the question here, this will display a chart with two labeled lines, and the way to do the bit with two labeled lines is telling me how to do it. I could have read the documentation, but inside of these square brackets here, inside of this square bracket, you've got one scatter chart, and if I like highlight all of that, that's one scatter chart. And then just down below, oh look, I've reached my limit for using GPTs, so I'm going to have to start asking on one of the other places. And then here you just put a little comma at the end of it, and then you've just put your second scatter plot. So I can literally just do that. So that's telling me, so I'm inside of the square brackets here, and I just hit, I should really hit a comma there. So, you know, I could even leave a little something or other. I guess maybe I'll put the go.scatter over there. I wonder where it looks nicer. I was going to hit return actually. The first plot. Right here, I'd actually create, so the second plot. Now I'm going to just do two plots. I'm going to do two plots in two different colors. I've actually done this earlier today. I did it on Linux on a Chromebook, and so I'm just going to do this again just for the purpose of demonstrating, but then I'm going to kind of like attempt to generalize it. So I'm going to go into here, and instead of having this like this plot, this chart, and here I'm going to have to pass in like two arrays, for example. What I want to do is to be able to like pump out like basically a list. I want to create a list of NumPy arrays is what I want to do. So the second plot here just looks like, if I do that again, just to remind, it's just a go.scatter again. So, and it looks nothing more than that. So I'm just going to kind of like take this first plot. So all of that, and paste that in here. Now, and probably have to close brackets. Close brackets. There we go. So we've got our first plot, we've got our second plot, and this will be reds. How about not writing in the middle? So something like that. I'll use capital because it uses a capital there, and name instead of being first plot. Now this is going to be second plot. Now I'm going to have to take in like an X, Y, Z, S. I've taken in one, but now I want to create another one, so it's going to have to be something like, I guess, where I run this here, just by way of example. Here, I'm going to create another X, Y, Z, S. Copy that, paste that here, and that will be something like XYZS2. And here, you know, we just change some of these numbers. Let's change that 25. So something like that. Let's just change these numbers. Let's mix up the numbers a bit. Right. And this plot charts then in that case is going to need a second object. So I would have to, if I go back to, let's just go to definition. This way it's going to need an extra one of these basically. So something like that. Look, it's quite clever. I think does it throw the error because it's used already, duplicate param, so I have to change it to a 2. And everywhere down here, I don't think I do any transformations on it. No, and they're the same length, so that's fine. 2, 2, 2. And the color equals colors, well, it's the same length array, so there's nothing to be changed there. It's just actually going to change the colors. It's going to be red, and it's going to be second plot. And I think that might be, so now somewhere down, where was it, where I'm actually calling it, now I'm commanded to put in the X, Y, ZS2, there we go. So, and I think that's basically it. So this one feeds in here, and this one feeds into here, and that should be sufficient to do the 2 plots. If I hit F5, I wonder if we throw in it, get an error thrown. I'm doing this all in live, so it might throw an error. Who knows? Showing the charts. Oh, is it going to work? Yeah, happy days. There we go. So we've got 2 Lorenz plots, and we notice that they're different as well. They do change in color. I want to get, like, I did see somewhere where like I had a little bar there, like a scale bar, telling us what it was. But anyway, we can see, so they both start here and then they start evolving and they spiral in different ways. And this is the chaotic part of it. So it's quite nice. So that's working, which is good. But I want to make like any number of these, so I don't want to have to keep on adding arguments into the plot charts. And the way to do this probably is to pass in a list of these things. So in plot charts, I want to have a list and then iterate through the list. So in this plot charts thing here, we want to have our these XYZs there. So it's going to be a list of NumPy arrays. So we'll call it curves, which are going to be a list of np.nd array. So be something like that. And now this will be I wonder if I can just do that, curves 0, because it's going to be the first curve. Copy that. And then I'm going to generalize this afterwards, so I think that should be fine. In here will be curves, these are all going to be 1s. We can see that it does look like it works because we're getting the colouring, which means that the transpose does exist, and it does exist because it knows that this is a ND array. It's one element of the ND array, so curves again here. So curves 1, and therefore in here now I can say that curves is actually some sort of list, and then in fact I can even go down here, X. I just paste it down here because curves is now going to contain this and this. Oops. So we can see where we're going with this if it works. So I'll paste that in here because I did a cut and not paste. So now here we're passing in the curves, and in our thing it says here that we're expecting a list of ND arrays, and this is our list here, and each one of these is an ND array, so it should produce exactly the same results. F5. Be really pleased if it does. There's no way that this is gonna... Oh, did it work? Yes, it has done. Happy days. So we get our same two curves. Wonder if I close the original one. There we go. We get exactly the same two curves. So page up and down. There we go. Same two curves. Happy days. So I can close that. I'll just go close that because I've got quite a few of these things open. Close that and then tab across. So this piece will be relatively easy because it's going to be some sort of for loop with some parameters. So and then we'll just populate. We'll do curves.append. So for I in, and we'll have to have some sort of parameters lists, SRB list, because it's going to be SRB list is this list of SRBs. So we're going to have to make some sort of list of SRBs. SRB, well, I'll have to create an SRB list. So SRB list. Right, so it's just going to be different values of SRBs. So it'll be something like, maybe it'll be a list of tuples, I guess. So 10, 29, 1974, 1, 2, 3. There we go. Put a comma in there. So that's our first item in the list, and the second item in the list is, I might make it a little bit clearer if I just split the list out like that, just so that it's obvious to the reader exactly what it is. There's our list, and I'm just going to put in the 12, 25, and 2006 by 1000. There we go. And I could just keep on making the list longer. But anyway, for SRB in SRB list, that our XYZS X thing is going to be, so I'll just comment this one out, don't need it. S equals SRB, the first element, 0. R will be SRB, there might be better ways of doing this, but this is a good starting point. And B is going to be SRB, the second element. So the first element, the second element, and the third element will all fit into here basically. So if I get my drawing palette back up, I'll hit undo enough times. In fact, I'll just hit, I think, delete, or not delete, bin, there we go. And that value basically will be the first thing here. This value here is the second item, and this value here is going to be the third item. So that's what it's going to do, and they're going to go to and compute. We will be computing this XRBS, and then we're going to add it into this curve thing. So we're going to do a curves.append. Basically, we're going to append our list. We're not going to have a list. It's not going to be a massive list, so a list is perfectly fine to do. So in terms of size, so we'll now make our curves. So is this empty list, and then here we can do a curves dot append x y zs. So there we go. That should have done it, which means I can probably comment this one out as well. We can actually delete them, hopefully, if this all works. So we're just iterating through a list, and we're passing this list. So we're iterating through this list here. We're passing these parameters into the Lorenz time series. We're computing our new curve, basically our curve. And so we're going to have two curves in this case because our list is two parameter lists long, and we're just going to append that, and then we're going to plot chart of the curves. At the moment, we still got just the two curves in there, and we don't cater for more curves at the moment, but I'm just going to check that this code works. So I'll hit F5. I could run and then run without debugging, I think it is. It's the same thing as hitting F5. Showing the charts, let's just check it works, and it still works. So we're getting closer. So let's go back. Now, the one piece that we haven't done is something like this needs to go into a for loop now. And that's the bit that I'm not 1000% sure on, but well. Right. So this piece here has got to be a for loop. And I wonder if I can create the for loop, the list here. So that's one block. So I can do a data equals. So basically, I think I can do that. Yes, I can. So data is equal to something, right? Which is exactly, and it's going to be this first plot and this second plot and so forth. Right. So we'll define data as an empty list, and then we're going to loop through the list. That's what we're going to do. So we'll do a for, and I guess we're going to do a for curve in curves, right? So we're going to do something like that, and our curve is going to be this item without needing the index now. because we're looping through each one of them. And I'm probably going to say, I'm just going to do here, I'm going to type hint, curve is of type np dot nd array, right? And this is going to be curve, and this is going to be curve, and this is going to be curve. So, and I think that's it basically. So for curving curves, curve is of type nd array, and then curve is, I wonder if I can do, copy that, probably cleaner to do that. Curve, which is of type nd array, is a go scatter, and that's what it's going to be. And then we would just do a data dot append. We could do list comprehension, but I think it's better or cleaner to do it in a for loop when the lines of code is bigger. Curve, right? So it's going to create this object, and therefore the only thing that I need to do is, they're all going to be blues is the problem, and they're all going to have the first name, because this is going to keep repeating. Is I might have to index some colorization. So I'm going to have to do some sort of color scales and depend that. And I don't know like all of the different types of color scales. So I will just have to go here and then go plotly go color scale list. Built-in continuous color scales, Plotly, let's have a look. There we go. I've got loads of things like greens, greys, oranges. Okay, so I can make my list like long enough. So I will be tabbing between them. Color scale list. That's a nice mouthful, but we're allowed to do that. And don't think this is, because this is a general function here, I need this list. This list would have to be kind of like in theory as long as this list. I could do some sort of looping operation, but all I want to do is have like, I don't ever want to get to more than 10. Like I want it to be an arbitrary number, so maybe you want 2 of them, or maybe you want 5 of them. But let's just see how many like colors we can get in this list. So because we can then do it with an indexing. So I could put, well, I'm not could, I probably will do, I shall do, I equals 0, and then inside of the for loop we're going to increment it after we've done it. So somewhere after we've done the append, we'll do I plus equals 1. So we're going to increment I by 1, and that will means that we'll be able to do the indexing. So I go back here and I'm just going to start picking some out, and it's going to be, so I want to do blues, reds, greens. So blues, reds, greens. And I'm going to kind of like, I think, because here's blues, I might just do it in order, sort of like greens, okay, greys. Greys. Oranges is here, so that's allowable. Well, let's do that, copy that. We'll have some oranges in there. I see purples as well. So we've got purples. I'm just doing all of the singer colours. Reds we've used. Grey, yeah, that's solar. I think that's kind of like it. They're all like I think, at least I'm guessing, but they seem to be all the monochromatic ones. So I'll leave it at that. Because these other ones, although they're curves, I don't know what ice will be, for example, but maybe it's like a multitude of colours. I don't know. It might be and it might not be. So I'm hoping that works. So we've got 1, 2, 3, 4, 5. We can have up to 6. So we could do something like, you know, we could put a statement in off, even in off. But we wouldn't want to enter the for loop if we've got too many curves. So, you know, in theory, we should put in an if statement if len curves is greater than len of color scale list. We basically run out of colors. Print not enough colors. The English version of colors is with a U and the American version is without a U. And then so we'll break out of the function quickly. That's kind of like the elegant way to do it. So anyway, we were going to go and get our colours, so now I don't have to do blues anymore like that. Whatever the first item is, so it's going to be blue, red, green, red, green, blue, blue, red, green, blue, red, green. There's no, maybe there's yellows. I can have a guess at that, but we'll see. But anyway, so now instead of doing colour, we can just do colour scale list I. So colour scale list, and we're going to index it. So we do take the first item from the list and the second one and so forth. The same thing here now, we've got to do name. And I might actually just use the colours. Because we have to have something in there, so I'll just probably, I mean, I don't have to actually put a name in there, but I could turn it into an F string, and really actually what I want to put in there is, we haven't passed in, I kind of like want to put in these 3 parameters, to be fair, but I haven't passed that information in with the list. And so the plot charts would need to get that, and the plot charts, which gets called down here, would need to get this information, so we'd need to take in an SRB value. So it will take in curves, and then it would have to take in SRB list. So it's going to get a list. That's going to be quite cool, actually. I wonder if it will plot it as a string though, so it's going to get a list. I won't do it yet, but I'll do it later because I just want to make sure that this works, and it's better just to, in order to make sure that it works, for curve and curve, plot, because I don't want to do too many changes in one go. I'm just going to put in again here color scale lists. There we go. So it'd be like red plot, green plot, blue plot. That's all it's going to say at the moment. And here now for plotting the data, I've got data equals, and everything in there now should just be data. I'll call this, I might call it, just for clarity, plotting data. There we go. Copy that, paste it over there. Plotting data.append. There we go. So that all of this stuff here, everywhere down to here, can be commented out. It won't be needed if it works. Not this commented out, because that's perfectly fine. But that would be commented out. Plotting data. So that should be perfectly fine. We've now replaced all of these lines of code, because we've bunged them all into a for loop and generalized everything. And I think if this generalization works, that is satisfactory. So we're going to hit the F5 button to run it. We are running. Do we crash or does it work? No idea. Whee! Here we go. It works. So I'm not going to push one up. I was going to sort of like guess yellows or something like that. But yeah, that's going to... I might leave that up for the sake of it, because it's just... Yeah. Do we need this? Don't need that. This was, by the way... getting started, yeah, here, like, that was where I got this figure.write. So you can't do fig.show, you have to actually read this. But I'm losing the will to live to read it, reread it again. But there is this image export. I think if I pip installed this Kaleido image export, that I might have been able to do a plot.show. But to be fair, it doesn't actually massively matter. It just produces an HTML file somewhere in my file system, which actually is quite convenient, because then I don't have to rerun the code. So it's not the end of the world to plot a file. So I'm okay. I'm cool. I'm cool with that. It plots in the root directory, by the way. That's where it does plot it. So we can go back, and that works now. So I can get rid of all of this code. Can now go. That's a huge amount of code. We don't like to repeat ourselves. So that's a huge amount of code gone. Whoa, look at that. Beautiful. And yeah, that's kind of like everything. So now we could say, so our plotting of charts, it takes a bunch of curves in here, but we also want to take in a list of the SRBs, like our three parameters, our S parameter, R parameter, and B parameter. So I'm going to take in an SRB list into here. And that is of type list, and it's a list of tuples, and the tuples are, I think, we'll add floats. I think they're floats, to be fair. So it's a list of tuple of floats. There we go. But anyway, in any event, this is the list. You know, these two things here, and these are my tuples. And I'm saying that these are floats, but actually this is an integer, this is an integer, so I could go int, and well, it doesn't, I'm not sure that this has to be an integer. I'd have to remind, like I could test it out, I could put in 29.5, let's do that. Is a float allowed? So we could just run F5, there we go. Yeah, of course it's going to be allowed actually, because, oh no, hold on. It needs the SRB list now, right. I won't muck around with that, wherever that 29.5 is. I'm sure float's allowable, because if we go back to our original code here, there's nothing preventing us from having these values being floats. In fact, if anything, are they likely to be? Maybe, maybe not. Who knows? Although I think this piece here, these bits here are hinting that they could be floats anyway, especially this 1.05, because now it is a float. Even if this wasn't, right, and if this wasn't, this one definitely is. So I've got to go down and I've got to pass in now this SRB list into our function for plotting the curves. So SRB list. Now, nothing's going to happen at the moment apart from it won't break because I've passed in the right number of arguments. If I run it, it should be fine. It should all run perfectly fine. And it does, it works really nicely. So I'll tab back, and by the way, I can get rid of a lot of this. Now, good coders apparently reduce the lines of code, so there we go. And now I can just make this list, I think, as long as I want. Oh, what I was going to do was I wanted to, in our comments, on our comment, this piece here where we named it, we can now just call it, because we've passed it in, and it's not used at the moment, is SRB list I, so we can index our SRB list. And we don't have to do any checks on that, because SRB list must be the length of the number of curves. So, because there's one curve for every SRB list set of parameters that was defined. So this check is more than sufficient. We're just checking that we've got enough colors in our list. So I could, or should be able to, just put in a comma and add in some more. So I'll add in another one now, and I'll put in a 6 there, and a comma, paste, and a 22. In fact, what I could do, like really to be like completely correct about this, is actually pass in the color list here, because then I wouldn't have to do a check of the color list. So that's pretty much what's going to be done. And that means that I can just attempt to run this bit of code, and there should now be 4 curves. And I'm going to change these values a bit. So there should now be 4 curves, and the 4 curves should start being blue, red, green, greys, oranges. You know what, I'll leave them lowercase because it was lowercase in the docs. I'm going to leave some lower and some up. Or is that poor practice? What did the docs actually have? Yeah, all lowercase. Blues, reds, greens, greens, oranges, and purple. I did want to try out things like yellows, all the colours of the rainbow: red, orange, green, red, orange, yellow, green, blue, indigo, and violet. So I've got a red, got an orange. There's no yellow, greens. Maybe yellow is too light or something. Green, blue, maybe indigo and violet. But are classified as the purples. So these probably might be all of the like single tone colours by the looks of it. So I'm just going to hit run, F5 to run it, and we should get multiple curves, I think. Yep, we do. Got a little tiny green one over here, and we've got our plots labelled, which is quite nice. Take it out and add it back in. So, and Plotly is a lot better than Matplotlib in that sense. So we can take out our reds. Well, these are the oranges. And we can see that this is the data, the 1225 2.006. We can take this one out. And notice, like, well, here this 6 is lower than the 25, you know, and it creates this tiny little thing down here at the bottom, that little one. The little zooming thing. I think it was somewhere in here. Yeah, there you go. You see it pop up and disappear. So that's that. And then our purples. So that's kind of like basically it. And I think there's nothing more to be said, really. That's it. So that's the end of this little live stream. That's all I wanted to do. So what we've actually done is, and actually the reason I've done this is ages of people I've actually used as the arguments or the parameters that go into the Lorenz Attractor function. So these are like, they're basically different birthdays of people, and everyone gets their own Lorenz Attractor. So the person born on December the 6th, 2008 gets a tiny little one, and so forth. So yeah, that's basically it. Happy days. Oh, I should put, there we go. There's no sponsors at all, so you can send some bitcoins over. There's a wallet address over here. You can thumbs up, like, follow, all the rest of it. This was live coding, by the way, so everything that is here. I wonder if I can, yeah, I can zoom out and in. That's quite cool. Everything that I've done is kind of like just live, and I've sort of like mashed around with it and managed to get it working. Sometimes these things don't work. So yeah, that's basically it. And yeah, like, follow, thumbs up, and get whoever to also subscribe and all the rest of it, because that's really helpful. And yeah, they can keep it going, and you can go on there and send some Bitcoin to this wallet. There you go. That'll be a nice little reward. And that's it. Thanks.